All right, let's try it again. All right, so good morning. So any questions from what we've been doing so far? All right, I'm not muted this time, so that's not the reason. Cool. All right, so yesterday we were starting to play around with putting Unix commands together using pipes to direct the output of one command into the input of another. We looked a little bit at input-output redirection, so we could run a command and put the results into a file, or read the input of a command from a file. And those are useful, command line tricks if we want to do something that needs multiple pieces. We can throw them all together on one command line. What I want to start working on today is the first sort of large topic in this course, and the thing that will come into play for a bunch of our programming assignments, which is shell scripting. So being able to take a bunch of commands and put them inside a single file, type the name of the file, and it will go off and execute the commands inside there. And that's nice if you just have, 3 or 4 things that you always want to do one after another. You can put them in a file and not have to type them individually. But there's a whole programming language we can use inside Bash or most other shells. There's notions of variables, conditional statements, input, output, looping. It's a very rich programming environment, but it's a wrapper around Bash, right, or around Linux. So the kinds of things we do in C inside a loop, we might increment a variable. We might perform a calculation. In a Bash script, the things we do inside a loop might be compiling a program, pushing a repository over to Git, running another shell script, executing some other command, making a network connection somewhere, moving things around from one machine to another. Much more powerful underlying building blocks. So shell scripting can be really powerful. I've become a real shell script addict over the past several months. I used to do everything in C. When I was younger, I used to insist on doing everything in assembly language. I'm older now. I don't have as much spare time. Sometimes I just like getting the results. And scripting is a really good way to get lots of powerful results without necessarily too much effort going in. All right. So let me address a question that I'm seeing in chat right now, which is this question of why is it that on some systems you have to do a // in front of a file name and in other systems you don't. So most shells, so let's talk about what happens when you type something. I type something into my shell, I hit enter, it says command not found. How does it know that's a command that's not found? Whereas if I say ls, it finds and executes that command. Most of these commands are not built into the shell, right? ls is not a part of Bash. GCC is not a part of Bash. Who is not a part of Bash. Bash is a really simple program in some ways. It knows how to do a few things like show me my current working directory, but it doesn't know how to compile a C program. It doesn't know how to edit a program. Okay? Bash really just kind of listens to what I type, and then it looks for something that might correspond to what I meant for the program to do. So if I say ls, Bash has no idea what that means. Okay? But what happens is it looks through the file hierarchy of the system for a program named ls. And in fact, if I say which ls, it will tell me which file it found on the system named ls. It found /bin/ls. So when I say ls, the Bash system looks for a file with the name ls, finds it under /bin, and then executes /bin/ls. Now if I make my own version of ls, right? Now when I say ls, it's running my version of ls. And if I say which ls tells me it's the one in my current directory. And that // that's what you have to type on some systems like the CTEX server. Typically, if you want to run something in your current directory, you have to put a dot in front of it. Okay, how does bash decide where it should look for something named ls? Well, there's a variable in bash. We're going to talk about variables today. But there's a variable called path. And path is a list of directories separated by colons. And when I type something in and it doesn't happen to be one of those built-in commands that bash knows, like pwd, it starts searching every directory on this path. And it searches for a file with the name, whatever I typed in. Well, the way I've set up our path, the first directory it always searches is dot. That's your current directory. Wherever directory you're in, dot is that directory. So if you compile a file in your current directory and you type in the name of that executable, bash will find it and it will run it, even if there's another system command with the same name. If it doesn't find the command in your current directory, it'll search local sbin, local bin, user sbin, user bin, sbin bin, and then it'll search for games and then some other stuff. Java directory, microchip, that's where the MP Lab stuff is. I do some Garmin programming, so I've got things tied in there. And so on. And you can customize this. You can set this up however you like. I set it up in my .bashrc to be a certain way. So that's why on our system we don't have to put a dot in front of a command that we want to have run. Right? If I have a file called ha ha ha, I can just say ha ha ha. Alright, so if I let me go into the server. Let me hop into my 224 directory, and I will make a script subdirectory. Alright, so I'm sitting in here, and I need to tweak something. Hold on. Alright. Alright, so I'm sitting in my directory. I want to make a simple script. So let's make a script called info. So there's a command called echo, which you can use to display a message. So I can say echo hello Nick. I can say echo the date is, and I can run the date command, and I can say your current directory is, and I can say print my working directory, and I can say number of people on the system, and I can do a who and pipe that into word count. Okay, really simple, just giving you an idea here, okay? So I have a file in my current directory named info. Alright, and theoretically, if I run this script, it should do all of these things. Have a little conversation with me. Alright, unfortunately, if I just say info, it's going to say permission denied. Alright, so let's talk about file permissions. So let's do an ls-l, and there's the name of my file, info. It was created September 25th, a minute ago, 123 bytes. It's owned by me. That's my username. This is the owner of the file. Each user is also associated with one or more groups. We don't really do a whole lot with groups in here, but my group is the faculty group. For you, I think that says students. These things over here, this is what we're interested in. These are the permission bits. Okay, this is what other people on the system can do with this file. And permission bits are a mask. There's really 9 bits. And they go in groups of 3. So these 3 bits correspond to what the owner of the file can do. These correspond to what people who are not the owner but are in the same group can do, and these correspond to what everybody else in the world can do, the general population, if you're not the owner and you're not in the same group. And there's 3 bits. The first bit is for reading, the next is for writing, the last is for executing. So 9 bits control the basic permissions on a file. And if, for example, this is a 110000000, that means the owner can read and write the file but not execute it as a program. And people in the group who aren't the owner and people who are in the world who aren't in the group can't do anything. They can't read the file, they can't modify it, they can't execute it. Alright, write these out in octal. That's the permission mask 600. So when I do an ls-l, ignore that first dash, that tells you what kind of file it is. But these 9 symbols right here tell me owner has read write and no execute, nobody else has any access. Alright, 755, that's another octal number. What does 755 look like? 111, 101, 101. So if I gave a file permission 755, that would mean the owner can do anything to it. Everybody else can read and execute, but not modify. Alright, the way we give permissions to a file or change permissions is with the change mode, change mod. And then we put in the mask, and then we list the file that we want to change the permission bits of. So let's do change mod 755 info. And now if I look at info, we got to spell it right. And now if I look at this file, the owner has read, write, execute. Everybody else has read, execute only. Alright, so I've given myself execute permission. I also went ahead and gave everybody else permission to read and execute the file. My default permission is really restrictive, so I can usually read, write, and nobody else has any access. And that's just a default I set up. Alright, so my file is executable now. And now if I say info, it should look through the path, see the first directory it should check is my current directory. It will look in there, it will find this file, info, it should execute it. And there you go. So it says, hello Nick, the date is Friday, blah blah, current directory is PWD, well that's not right. Number of people on the system, 1260, 653. Alright, so let's clean this up a little. Let's correct our typos. Let's put some comments in. Alright, so let's dig into the bash syntax. So if you want to make a comment, go ahead and put a number sign in the beginning. So this is a comment. Okay, white space is usually ignored. If you just put in a blank line, it won't do anything about that. It just ignores it. Okay, which is good. All right, so let's comment the heck out of this. Give a greeting to the user. So hello Nick. Tell them what the date and time are. The date is date. Where are we? Your current working directory is, so PWD needs to go on a new line. And then, how busy is the system? And tell us how many people are on the system. Alright, so this is a little better. The date is Friday, current directory is, there's my directory name, number of people on the system, 12. All right, let's clean up that number of people on the system. So I'm using the word count instruction to count the number of lines that the who command prints out. If you look at word count, one of the first options it lists is -L. If I do word count -L, it'll print the number of new lines it found in the file, basically how many lines of output I got. So let's change that. Let's put a -L switch. All right, and a little note to myself, the -L means just give me a count of the number of lines. All right, so now I can run info, number of people on the system, 12. All right, so it's a goofy little example, but it's just kind of giving an idea. But I want you to think about commenting while you're writing code. Okay, almost everybody that I encounter seems to write code at the end of an assignment. They're like, okay, I'm just about done. I have to write my README and I have to add comments. Teachers ask for comments not just because, you know, we want to give you something more to do on your homework. Writing comments is for your benefit. Writing comments is essential when you're developing code to help you understand and remember and be clear about what's going on in the code that you're developing. All right. Now this is a really short script, and you know it's pretty obvious when I say hello Nick that I'm giving a greeting to the user. So these are kind of superfluous comments, right? But when you're in a larger scale project and you have lots of interdependencies and you have lots of variables, especially if you're working in C or something that's not, you know, object oriented, it's really easy to get confused. And a lot of time that I see students spending on debugging code is coming from their own confusion about what they're doing, right? Because we don't work as programmers, right? We're students, we're parents, we're caretakers, we're all these other things. And when we get a few moments, we do some extra coding on our project, right? And then we go away and we come back to it when we can. That's an environment that's really ripe for losing track of where you were, what were you doing, why did I type this in. That's what commenting will help you keep track of, right? So get into commenting habits, get into habits of leaving notes for yourself, right? Don't write comments for me. I'll ask you to put a comment block in the beginning of your program that tells me your name and the assignment and stuff like that. Everything else you write is for you, okay? For your future self, so that when you come back to this, either, you know, tomorrow or at the end of the week or 6 months from now, or when you're at a university and you're trying to remember how we coded Dijkstra's algorithm, right? When you come back to this stuff, you can make some sense out of it without having to reverse engineer the actual code, okay? And somebody posted something in chat saying if you want to learn the value of comments, write something in assembly language. Absolutely. Because, you know, without comments, you're reverse engineering the code. This is pretty easy to reverse engineer, right? What am I doing in this line down here? I'm telling me, you know, what my current directory is. That's pretty straightforward to read, right? Java is harder, C is much harder, assembly language really, really, really hard. Machine language, forget it, right? If you try to write directly in ones and zeros, definitely want to do a lot of commenting. All right, that's my comments about comments. Let's look at the echo command. So echo is pretty straightforward in a lot of ways. I can say echo hello, I can say echo hello there, and it basically repeats whatever I ask it to echo. Echo will do other things as well. So one of the more useful switches, echo-n, do not output the trailing new line, because when I say echo hello, I didn't say echo hello followed by a new line, but it assumed that's what I wanted it to do. So it output the thing that I asked it to, HELLO, and then it went down to a new line before it exited. If I say echo-n hello, it outputs exactly what I asked for, HELLO, and then it exits, and that's where my prompt begins, is right after that output. All right, so we can make our info program just a little better. We can say echo dash n the date is, and it will give us the date on the same line. And we can do that here also. Your current directory is, number of people on the system. And now it looks, almost like a reasonable program. All right, so echo is for generating output, and mostly we just say echo, or we say echo dash n if we want to be on the same line. Let's talk about variables. So we can set up variables in Bash, just like we do in C or other languages. I equals 5. All right, I've just made a variable I, I've set it equal to 5. Now if I echo I, what's it going to say? It's going to say I, because echo just repeats whatever you ask it to, right? It's an echo. But if I want the value of the variable I, put a $sign in front. So $sign something means give me the value of the variable named something. Okay, it's an indirection. If I say A equals 123 and I echo $sign I is now 123. If I say I equals ha 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 and I echo $sign I is ha ha ha. Okay, variables can have any value. They don't have to just be numbers. And you don't have to say I'm going to hold a number, I'm going to hold an integer, I'm going to hold a string, I'm going to hold a boolean. They're just boxes that you can put things in. They're just plain old variables. I can say I equals and not give it a value, and if I echo $sign I get an empty line. If I say I equals this is a test, I get into problems. So, talk about spaces and quotes. So spaces are really, really, really important in Bash. Okay, make sure you make a note of this because it'll come back again and again. Spaces are really important in Bash. C, Java, Python, most other modern languages, spaces don't matter unless they're inside, a quoted string or something. I can say I space 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 equals 20 spaces 15, and it'll say I equals 15. If I say I equals 1, it's going to complain. All right, so in assignment statements, you have to say variable, whatever you call it, followed immediately by an equals sign, followed by, whatever value you want to give to it. That'll work fine. And then if I say echo $sign variable name, it shows me the value. Let's see, question, why does echo recognize I? You said echo just repeats what you ask. So if I say echo I, it just echoes I. But if I say echo $sign I, that says show me the value of I. So $sign is special, right? You're welcome. Let's see, someone says, I noticed Bash didn't ignore whitespace when PWD needed its own line. I don't remember exactly what that was. So I had PWD sitting up here, like that. And it basically just echoed your current directory is PWD. So Bash doesn't echo the quotes if you put something in quotation marks. So if I say echo hello, it says hello. If I say echo quote hello, it still just says hello. So quotation marks are a little special also. All right, so variable equals value, can't have any spaces. So if I want to say, let me stop calling it, let me call this greeting. Greeting equals hello there, can't do that. You can use quotation marks, right? Quotation marks are a way to group things and say greeting is equal to all of this stuff inside the quotation marks. And now I can have spaces inside there, and that's the value of the variable. But multiple spaces get consumed and shrunk down to one space. So that's a little goofy too. All right, so here's the next really important thing to remember about Bash. Bash is not C. Bash is not Java. Bash is not Python. Bash is Bash. And for many years, I refused to do Bash programming because of things like this, right? The fact that if I said greeting equal to a quoted string with a bunch of spaces in between, all those spaces get shrunk down to one space. Bash has its peculiarities. It's a quirky kind of programming environment, especially if you're coming from years of rigor, right? Working with very dogmatic languages and environments. But if you can make peace with this, it's actually a really kind of comfortable way to program sometimes, right? The sort of sloppiness, relaxedness of it can actually be beneficial. And it really took years before I sort of got past my kind of classism about Bash and started using shell scripts, and then just kind of fell in love with it. So when, this is the third thing about Bash, when you're working with Bash, really, or any language, especially shell scripting, you want to be doing a lot of experiments, okay? And Bash, you know, we don't have to compile it. We can do things on the command line. If I'm going to write a script that's going to, you know, echo something with spaces inside and it's not working, I don't have to modify my script and run it, modify my script and run it, and all this kind of stuff. I can do the stuff I'm going to do in my script from the command line directly. I can say something like, you know, like this, and I can see, oh, well, that worked. Okay, so why didn't it work when I assigned hi, hello there to a variable and tried to echo that out? Well, if I echo $greeting inside quotation marks, my spaces come back. And you have a couple of choices, right? You can, well, you have three choices. You can throw up your arms in frustration and leave Bash, like I did. You can spend a bunch of time trying to understand why this is happening, which I've done, or you can just live with it, which is what I do now. I find a way to make it work, and I kind of run with it. So this is different from C, right? And you will not hear me give these suggestions when we're playing with C. C, I want you to understand everything that happens, okay? Because C is basically assembly language, which is basically hardware. And when we do something a certain way in C and it doesn't work, I want us to understand why. When we change it and it does work, I want us to understand why. Because those lessons will teach you about assembly language and about hardware and about the operating system sometimes. But this stuff in Bash, if we spend a lot of time trying to understand why we get that versus this, it'll teach us about Bash and about the mindset of the people who develop Bash, but not necessarily a whole lot more, a whole lot outside of that. All right, so that's kind of cautionary tale. And these things don't come up, they won't come up in the stuff that we're doing in this class, but down the road. All right, so we have variables, right? So I can set I equal to 5, echo $I is equal to 5. Okay, I can say I equals I plus 1. What do you think the value of I is? I plus 1. I equals 5. Let's confirm I is equal to 5. I equals, let's say $I plus 1. Let's be fancy. Let's replace that $I with the value 5. So now we'll set I equal to 5 plus 1. I should be 6. What's I equal to? 5 plus 1. Okay, it's very literal. Right? All that Bash knows is you're trying to do a symbol assignment. When you say $I, you want to replace it with this stuff. All right, I'll give you a sneak preview. If you want to do math, here's how you do it. $, paren, and then an arithmetic expression, and then 2 closing parens. If you do that, you'll actually do arithmetic. All right, we're not going to have to do that today. All right, so spaces and quotes, variables. Once we have variables, we can start talking about input. So how do we read something from the user? Use the read command. So if I say read I, the system sits here. I have not gotten my prompt back yet, which tells me that Bash is not waiting for a new command to execute. In this case, it's waiting for me to type something in, which will become the value of I. So what is this? All right, now if I echo the value of I, it's the string. What is this? So we do input with read, we do output with echo. We do arithmetic with this funny $paren. If I say read x and I type in 23, x is equal to 23. If we say read x and I just hit enter, then x is just equal to an empty string. And if I ask for a variable that I've never given a value to, that's also just an empty string. So we have a much more kind of fluid, forgiving environment from C, for example. C, if I try to say I equals 1, and I haven't said integer I somewhere prior to that, I get a compile error. If I try to set I equal to a quoted string, and I is supposed to be a float, I get a compile error. If I want to print the value of I have to say printf parentheses double quote %d \n double quote comma I close paren semicolon. Here I can just say echo $I. And I could be an integer, and then it could be a string, and then it could be a floating point, and then it could be a string again, and then it could be another integer, and Bash doesn't mind any of that. And it could be a really big looking number. Alright. And I don't get a rounding or a truncation or anything because it's just a string of characters. But if I want to do something with that, then I've got to deal with the realities of you know, a fixed word size. Integers that can only go up to a certain value and so on. All right, so it's a very different feeling from a compiled language like C or Java, where we have lots of strong typing and things like that. All right, well, if you want to make a general purpose language, you need 3 things. You need a way to execute sequential instructions, you need a way to do conditionals, and you need a way to do looping. All right, sequential execution, that's what we've been playing around with so far in our little info program that just executes one instruction after another. So we need conditionals and looping. So let's talk about conditionals, right, or if statements. So let's make ourselves a goofy little command center program, which will let us edit and compile and execute programs without having to remember VI and GCC and all that kind of stuff. So,
I think you muted yourself again.
whoa, how did that happen? All right, hopefully it hasn't been for long. Thank you.
Yeah, that time it was a few seconds.
Okay, good, thanks. All right, so let's make a command center program. Let the user edit, compile, execute programs. All right, so this is just an example. All right, so echo welcome. All right, first thing we're gonna want to do is we're gonna want to loop. Okay, so let's talk about loops also. And loops. All right, easiest loop to work with is a while loop. We can do for loops in Bash. They don't really follow the same structure as most of the other statements, so I'm not going to talk about for loops. I'm going to talk about while loops, and we can always do a for loop with a while statement. Okay, so what does a while loop look like? Basically, while space, bracket, bracket, space, some condition, space, bracket, bracket. Okay, space, 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 no spaces, no spaces. Really, really important. Okay, so while condition, do, bunch of statements you want to do, done. All right, so before we do our command center, let's do a simple looping test. Hold on, I just lost my chat window. All right, there we go. All right, let's make a looper program. I equals 1. While bracket bracket $i is less than 10. Do echo I equals $i plus 1. Done. All right, so conditions in Bash. If we want to compare numbers, we use things like -lt for less than, -gt for greater than, -eq for equal, and so on. Okay, so this is a numeric computation. So compare numbers. We're going to do things like that. So this should output the numbers 1 through 9, and when I gets up to be 10, it should exit. Alright, so what do I have to do to make this thing executable? Change mod, perfect. Alright, run this again. There's our loop. Alright, if statements. If space, bracket, bracket, space, condition, space, bracket, bracket, then whatever we want to have happen, and we end our if block with the word phi. It's if spelled backwards. So let's put something in the middle of our block here. Let's echo I. If bracket $i equals 5, then echo halfway done phi. All right. Pretty straightforward, but very unusual syntax compared to what we're used to. What we might be used to if we do a lot of C. All right. So let me mention something here. There are a lot of ways you can write things like this in Bash. Okay, there's a lot of different variations on the syntax. This is one of the few cases where I'm going to insist that you follow this particular syntax. When you're doing assignments, when you're doing quizzes, when you're doing exams, if I ask you to write a while loop, I'm going to expect it to be exactly like this. While space, bracket, bracket, space, condition, space, bracket, bracket. Next line, do. All of your stuff, separate line, done. Okay? You can do it sometimes with one square bracket. You can do it sometimes with two parentheses. You can do a semicolon at the end and then put the word do on the same line. I'm going to insist that you do it exactly like this. Not because this is the best way to do it, not because it happens to be the way that I do it, but because I want to make sure that everybody knows how to write a while loop and how to write an if loop, okay, an if statement. And you can do this with one bracket, and sometimes it will work. And if you write this with one bracket and it happens to work, is it the case that you're a very savvy Bash programmer and you knew that one bracket was sufficient, or did you get lucky? Right? More often than not, the student got lucky. And then when they're off on a job interview or working on a job or working on another assignment, they think they can use one square bracket, they can't, and they've got a bug somewhere in the middle of a script, and it's a very mysterious bug to try to hunt down. So if you're a proficient Bash programmer, I apologize because I'm going to force you to do something a particular way. If you're learning Bash and Bash programming for the first time, please stick to this way. Okay? Do this, and this will be consistent with everything that we do in class and everything that I write on the display and every piece of code that I show you as a sample. And consistency is good. Okay? Consistency is a key to learning and getting efficient with things. So while loops look like this, if statements look like this. And if statements, if you want to have an else statement, you can say else, and then put in some else statements, and then put your fee down here. And if you want multiple if-thens inside your block, you can say elif. That's the abbreviation for else if. And then you can say bracket, bracket, another condition, bracket, bracket, then list some stuff, and you could have another else if, you could have an else, or you can just have a fee. All right, questions so far? We got 5 minutes. Let's write a little command center program. All right, here's my infinite loop. Fee means end of if. It's like a closing curly bracket. So for Bash, then is like an opening curly bracket, fee is a closing curly bracket. It's just the syntax that the language uses. All right, infinite loop, echo, enter C to compile, E to edit, R to run, Q to quit. All right. If we're trying to compare numbers, we use -EQ, -NE, -LT, and so on. If we're trying to compare strings, we use equal, equal. So use equal, equal, or exclamation mark equal for comparing strings. And I'll post a summary of these things on Canvas. I've got a 1 or 2 pager that shows you examples of all of these things. But the punchline, numbers, we use -LT, -GT, and so on. Strings, right, collections of symbols that we want to compare, use equal, equal for comparing the same, exclamation mark equal for different. All right, so if command is equal to this thing, then exclamation mark equal is not equal. All right, so if we want to edit our file, and let's say vi hello.c, else if command is equal to compile, then gcc-o hello.c, else if command is equal to run.
You made a typo.
I did not. Else if command is equal to r, then I'm going to say /hello just to remind me that this is a program in my current directory. Else, else if command is q, then, and I'll do a break statement which takes me out of my loop. Else echo what? There's the end of my big long if statement, there's the end of my done. And then when I break out of my loop, I'll just say echo goodbye. We got 50 seconds. Let's see if this works. Okay. Command is a built-in command in bash, so that takes precedence over the path. Okay, compile, editor, run. Let's edit our program. Hello.c. Alright, there's my program. Let's compile it. Looks like it compiled, except I didn't do standard I/O. Let's go ahead and run it. And there's the execution of it. I can edit it again. I can put in my standard I/O. I can recompile. I can run it. It works fine. I can quit, and I'm all done. So just an example, right? Not terribly useful in general, but what would be nice is if we had the option of specifying a program so it didn't always compile hello.c, it didn't always execute hello, but if we had an option in here where we could say what file do we want to work with. So if you want to mess around with this a little, try to modify this. Add another option like S for select a file, and if I type in an S, have it ask me what file I want to work with, and I can type in hello, and then this will vi, hello.c, or I could type in, program 5, and this would vi program 5.c. This would execute program 5, and so on. All right, we are out of time. I will see you next time. Have a great weekend if I don't see you in 2:15, and I'll see you on Monday.